going to talk about my personal journey to continuous cloud compliance. So who here has either implemented a continuous cloud compliance solution or is thinking about doing so? Quite a few. And for those of you who haven't, if you've got anything in the cloud, maybe by the end of the talk you might decide to. We'll see. This is based on some of the work which I've done with a few different customers. And in both cases, actually, I joined a DevOps team. And in one particular case I'm thinking of, I joined the DevOps team as their first really hands-on security architect. This was for a reasonable sized organization. And there was already a sort of central security department. But I was the first security engineer that actually became part of the DevOps team. So I was going to every stand-up and actually coding security features and making improvements. So that's me smiling. So I started off by being very polite and nice to everybody. And as you can imagine, it didn't really last that long. So the sort of background was that when I came in, there was already a production application in Amazon, hosted in Amazon Web Services, AWS. And this was maintained and developed by around 30 to 40 DevOps and CloudOps engineers. And as you might expect, we used an agile development process, 2-week sprints. Every sprint, there might be 30 different stories. Most of the infrastructure was coded, which was good. However, there was some manual configuration as well. And my role was to encourage good security practice and help to improve the security of the platform. So when I joined, I started off by thinking, well, what I should probably do is find out what the security requirements are. Not a bad place to start. And I was told that, and in any case, I would have done this myself, that we needed to comply with the Center for Internet Security Amazon Web Services Foundation benchmark, which is a good place to start. Have some of you familiar with this? Yeah, good. It's a very good starting point for AWS security. There are 43 controls across 4 domains, and these include identity and access management, logging, monitoring, and networking. And that's not to say that all you need to do to make your infrastructure secure is pass all those tests, but it is a good starting point. So I started off a bit naively, logging into the console, getting myself an account on the different accounts. There was some separation between development and production, which was good. And I started off manually logging into the console and seeing what I could see, and then going through in a fairly manual way which of these controls are actually complied with. And what I've found, as you might not be surprised to hear, was open security groups. So security groups being the host-based firewalls around virtual machines in EC2. Open security groups with inbound from any to SSH, for instance, which is bad from a security point of view. Dangerous identity and access management policies. Some was so miscoded that they could actually allow takeover of the account from any AWS account through a miscoding of the assumed role. Public S3 buckets. Access keys not rotated. The Center for Internet Security Foundation benchmark says access keys should be rotated every 90 days, and they weren't being. It's much easier as a DevOps engineer not to bother to rotate your access key and just leave it. So what I quickly found, well, firstly, there were some things I could fix myself, which I did, and I asked people quite nicely and politely to fix things. And it's probably not a surprise to you that a few people did what I asked. And some people said, oh, yes, and then just didn't do anything. And the others just told me they weren't interested and go away. So not a big surprise. So I thought, and also the other thing with this manual review was that I quickly realized after, I did it for about a week. And then I realized this is just not sustainable. This is ridiculous because, firstly, it's too much work to go through all the different regions and all the different accounts and all the different things. It's not going to work. And secondly, even if everything looks absolutely fine one day, the next day somebody's going to do something that's not secure. So the first thing I realized is that this all needed to be automated. And initially, the discovery needed to be automated. So that was the first thing I did. So I thought, well, I don't want to do this myself. And I don't want to code it all myself. So what is there out there? I asked around, had a look on GitHub, and came across NCC's Scout2 tool. So is there anybody here from NCC? Yeah, well, thank you very much for putting a nice, it might not have been you personally, but thank you to NCC for putting a good tool, on the, open sourcing a good tool and also maintaining it. So let's have a look at this. Right, so I'm going to just run the tool against one of my AWS accounts. Now, because running the tool, so the tool is just a set of Python checks. It requires a read-only account configured. And to do the whole scan on all the different AWS services in all the regions can take a while. So I don't want to bore you with that. So I'm just going to limit this to initially to one particular service. So I'm going to specify that it's just one particular AWS account because in my AWS credentials file, I've got several different profiles. And I'm also going to specify, thank you. Sorry about that. I thought it was mirroring, but it's actually a drag, isn't it? So thank you for letting me know. But this is what I did just type. This wasn't, I did actually just type that. Right. So, right. OK. OK. So, hold on. Right. This is more challenging now. So now I'm going to do service. What I really want to do is mirror them, if you can do that. Right. So I'm only going to look at the identity and access management service. So what this should do now, and I haven't tested it today, so who knows what's going to happen, is it should go into that particular account. It should look at the various groups and users and then analyze that. So I'm just going to type yes to override the files I had before. So this is the results of a subset of that scan of the account. So sorry about this. Right, here we are. Right. So if I go down, right. Would you mind just mirroring the screens for me? So would you mind just mirroring them instead of extending them? Technical, little pause. Thank you. Excellent. Sure. OK, so this is the result of the scan. So these are grayed out because I only chose to look at the identity and access management service. However, if I was to click in here, I'll see the results of that particular scan. So red is a complete failure of that particular control within the Scout2 test. And most of these do correspond to Center for Internet Security benchmark controls. Green means good, gray means not applicable, and obviously amber means warning. So you can see that this has picked up some useful information like lack of key rotation. So if I was to click on one of these, I can then find more detail. So that was great. And yeah, I'll just show you another one as well, actually. So that particular test was looking at identity and access management. So let's just do another one, a similar one, looking at S3 buckets and see what we see. So I'm going to limit this to S3 buckets only. And, oops, sorry, forgot to put the 2. Scout 2 should be better. So this is looking actually in a different account at any S3 buckets, S3 being used for storage, to see, do these follow the standards and good practice generally. So moving down to S3. You can see that there's some problems here. So for example, get actions are authorized to all principals. In other words, it's public. And this is quite impressive, actually, because with S3, you can look at both. There are 2 ways of controlling the access. One is through access control list. The other is through a bucket policy. And it is important to look at both. And this particular test does actually look at the bucket policy, which is good. Well, it's good that it looks at it. This is not a good bucket policy, unless you want to make your buckets completely, completely readable. So that's one example. So moving back to the PowerPoint. I could then do regular automated scans, which is good. So I now no longer had to manually look at the console. However, I then still had to ask people to do things. So I'd say, this is the list of people whose keys are older than 90 days. Can you rotate them, please? Can you please reconfigure your security group to be more secure? And as before, the answer tended to be, yeah, okay, or no. So I realized that while this has helped with the detection and the automation, it hadn't really completely solved the issue. So I thought, well, what we need to do, we've got the detection in place. We've got some nice detection. This could be automated to run on a daily basis if I wanted to. What we really need is to actually work on some prevention. So obviously, it'd be nice to be able to prevent and put in place certain rules for the whole AWS account or the whole Azure subscription. And nowadays, and even to some extent back then, but particularly now, there are some good tools to do this. So with Azure, there are Azure policies, and you can put in place certain policies that say, for example, you can only deploy resources in certain regions. And then that applies to the whole subscription. So that's very powerful, and that prevents certain things happening. With AWS, we now have organizations, AWS organizations, and we now have service control policies. So we can enforce certain policies on any subscription, any account, AWS account, within that organization in a hierarchical way. However, even though we have got those, they won't cover all use cases that we might want. And in any case, at the time that this happened, they weren't available. So I started off by writing some security tests in Python and integrated these to the CI/CD pipeline. So we were using a CI/CD pipeline, which is good. And I created some Python tests that weren't very complicated. And some were to check for unsafe security groups. Some were to check for identity and access management roles that were unsafe. And you might think that that did the trick. Well, it certainly helped. However, what I then realized was that not all repositories were actually integrated to the pipeline. And worse than that, some people were still doing things manually. So there were still cases of people going into the AWS console and pressing click, create virtual machine, next, next, next. And then you get a launch wizard, and which automatically has a security group of inbound from any. So this helped, and it helped to make sure that some unsafe practices didn't get into the main code base. However, it wasn't enough to make sure that the AWS accounts were actually being well maintained. So I'll put in some prevention. I'll put in some detection, put in some prevention. And then what I then realized was that to actually really make more progress, I needed to put in some automated remediation and enforcement. So for this, I used, again, I didn't want to write anything myself if I didn't have to. So looked at what was out there and asked around. Came across Capital One's Cloud Custodian project. So anybody here from Capital One? Yeah, at least one or two. So again, thank you to Capital One for putting this, open sourcing this, and again, and for maintaining it. And I noticed that the most recent release appears to have some Azure and Google Cloud functionality as well as AWS, which is great. Haven't looked at it yet, but that's it's good. So I put that in place. So what I'll now do is show you that. So the technology used Cloud Custodian, as I said, from Capital One. I also created additional Lambda functions for notifications, for customized notifications. And then some of the example policies, which I'm going to show you, are, because this is a DevSecOps conference and we're talking about security, I'm going to show you the security-related ones. However, it is important to note that, that Cloud Custodian is not just a security project. It's also very good for cost control as well. The examples that we're going to look at are requiring a multi-factor authentication token for users, enforcing access key rotation to comply with the requirement within the SIS benchmark that every 90 days access keys are rotated, and another example being solving the open security group rules. So that is the aim. So to give you an example of a Cloud Custodian policy, the nice thing about it is that you could just define what you want to happen in a very simple YAML file. So this particular policy is to delete an access key. And it's saying that you want this to happen once a day. In this particular case, it's a scheduled task. In some other cases, for some other functions, other policies, you could say it's triggered by a different event, like a config event. And you want to look for an access key that's older than, in this case, 100 days. And if you find it, remove the keys and then notify. And a bit further down, there'll be a block, or a couple of blocks saying where you want the notification to go. So in this case, email and Slack. So that's an example policy. That then, through a simple command line, deploys YAML file, deploys Lambda functions, assigns a identity and access management role to that Lambda function, and then integrates with a simple notification service. So it takes a lot of the effort out of creating these policies, because that's already been done. So let's see if this works. So this is an AWS account. And you can see here that there are some problems with access keys by looking at the bottom warning. If we go into users, you can see that some users haven't got, well, most of the users haven't got multi-factor authentication enabled. You can also see that there's different groups for different users. And for this particular demo, I'm only looking at one particular group, which is this custodian group. This is just to demonstrate to you. So this is currently set to, as you saw from the policies, these policies I happen to have set them to run once a day. So I'm going to trigger this manually just to simulate what happens once a day. So interestingly, I think the daily time this happens is actually around now, but not that that really matters. So I'm going to go to Lambda. Oh, and by the way, I've worked with AWS for years, and I only just discovered that you could pin these different services to the top. And I was so pleased when I actually discovered that. And I thought, why didn't I realize that before? It's really good. So now I'm going to use it because I'm pleased with it. So I'm going to click on Lambda. And what I'm going to do is go down to the policy that says, that is the Cloud Custodian policy for warning about multi-factor authentication. And I've just set up a scheduled test to simulate the CloudWatch scheduled event of once a day. And I'm just going to click test. So this should just kick it off manually so that we don't have to wait 24 hours. And we'll see what happens. Always good doing live demos. Anything could happen. Well, that succeeded. So we have received a Slack notification. So here it is. So just received the message. So this message is to the whole channel. In this case, it's just me. In the real case, this was 40 people plus the manager. And then it automatically finds out who the person is from their name, and it says, assign a multi-factor authentication token to your account now. And it also says which account, because in a real case, you'll have more than one account. So what I found was suddenly people started doing what they were supposed to, because when I just communicated with them one-to-one and said, oh, can you assign an MFA token? Oh, yeah, and then they didn't do it. This time, they were embarrassed in front of their senior manager and very quickly did it, and so that it didn't appear the next day. So that was very effective. So that's one. Let's try something else. So we'll go back to another Lambda function. So one of the other tests that I've got set up here is warning about access keys being out of date. Again, I've set it up on a scheduled task to run once every 24 hours. So you don't have to wait 24 hours in this room. I'm going to kick this off manually. Here we are. So again, I'm just going to go into this Lambda function. And I will trigger the task. So what this will be doing is this will be, according to the Cloud Custodian policy, it will look through identity and access management in this account. It'll look at the filters, so which groups and users to look at. And then for those groups and users, it'll be looking at the age of the access key and then making a decision as to what to do based on that age. So we seem to have received another notification in Slack. And although I'm showing you in Slack, I do also get an email as well. I just thought, do Slack, it's more DevOpsy. So we do get this warning as well. Rotate your access keys and delete old keys in your AWS account. Keys older than 90 days will be deleted. So that was one policy. That's like the warning. And then there's actually two more that I've got. One which then disables it at 90. This was at 80 days, this one. And then 90 days it was disabled. And then 100 days it was deleted. And as with the other one, I found this to be amazingly effective, because especially as this actually disabled the keys. I mean, I did have to be careful with the filters, because there were some keys that were being used by services, which actually it probably shouldn't have been, and that's another story. And I didn't want to accidentally break anything in production, so I had to be pretty careful to make sure that I only captured the users. However, it was extremely effective, because the keys actually got disabled and deleted. So all of a sudden, these DevOps guys, and they were guys, who previously had mostly just completely ignored me and carried on doing what they wanted to do anyway, they now started doing things like, oh, I'm going to write a little script to rotate my access key and share it on our repositories, and and so on. So that was also very effective, which was good. So the next one to show you is one of the challenges that was hardest to get rid of was the open security groups. So what I'm going to do now is, as this event is being held in London, I thought I'd set this one up in London. So I'm going to go to EC2. And I'm going to go to security groups. And what I'll do now is create a new security group. So I'll call this group DevSecCon London. And I'm going to put in a rule which says SSH from any is allowed. This is what you should not do. So here's the rule. Here's the group, and here's the rule. Oh, sorry, I did all. I meant to do. Let me edit that. Sorry about that. Let's just get this right. That's what I wanted to do. Right. So SSH from any is allowed. So this is what would be created with click, 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 next, 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 launch wizard. Or programmatically, for somebody who doesn't want to bother to find out their own public IP address for a development project. So we have this unsafe security group. And we also have another cloud custodian policy that will correct this issue. So again, this one I've actually set up to run once per hour. I could have set it up to be triggered from AWS config. However, when I tested it, that didn't seem to make a lot of difference in time. That wasn't necessarily immediate either. So I've just set this up as a once per hour event. And again, to say we don't have to wait up to an hour, I've just set up a test event to simulate that. So I'm running this function. So this will be looking at all the security groups in this particular region. So let's see if that did anything. So we'll go back to EC2, look at this security group. So you can see the rule has been removed by Cloud Custodian, and helpfully they've put a little tag in to say, please restrict source addresses. See, I put in a please. I was being nice. Sorry. Yep. And we have got another notification in Slack. So this notification, so using the warning color, security group has been edited to remove a rule, name of the account, name of the security group, and the security group ID. So like with the access keys, I found that to be extremely effective at changing behavior, because firstly, whatever they were doing stopped working. And secondly, again, it tended to embarrass the people who were doing it. So it was a very effective way forward. So having done that, I then thought, well, I better start looking at something else now. So the next thing I started looking at was keys and secrets. And that was a whole other problem. So to start with, I thought, well, let me do a few scans. So as with everything else, I didn't want to reinvent the wheel. Had a look at what was there on GitHub, asked around, and came across GitRob. I guess, have several of you used GitRob? OK, well, I'll show you GitRob. So GitRob is an open source tool that is, can be used to scan GitHub repositories, both public and private. So to show you this, I'm going to type GitRob analyze, spelt the American way, and then the name of my organization, Celidor. So what this will do is this will look at this particular organization, and then it will scan all the repositories and then look for signs of potential keys and passwords in repositories and then flag them up. And what I should say is that I created for this demo, I created a deliberately bad repository, which I'll show you here, called insecure. So in this particular case, it's quite a small repository, so it wouldn't actually be hard to just go through manually and look at all the files. But in a real example, you could have hundreds or thousands of files, which are just too cumbersome to look through manually. So let's have a look at what came back. So the scan which I've just done is shown here. So you can see that a number of suspect items have been identified. So as an example, some AWS access keys. So feel free to try these, but as you would expect, what I did was to create an access key pair, and then I did delete it before putting it up to the repository. And I would say this is a real issue. I mean, I was at one of the organizations I work with. I was sitting at my desk about at 10:30 in the morning and got an email from Amazon saying, you know, your AWS account has been compromised. This key has been found in public GitHub. So fortunately, I was there and immediately read the email, and fortunately, immediately logged on and to the AWS console, found it, and straight away deleted it, and then went ahead and checked everything, and it seemed not to have been compromised in that time. It was also, fortunately, the dev account. The DevOps person who did that was suitably embarrassed. However, I would say that this is a really easy thing to do, so I wouldn't be too critical, especially as I have done much the same thing myself to a private repository, so I know how easy it is. Anyway, access keys is one example. Another example, which I found to be quite common, is RSA private keys. So one might think, well, why do DevOps engineers put keys into code or passwords? Well, what we want to do as DevOps engineers is automate everything. We don't want any manual processes. And putting keys and certificates and passwords into a code repository is actually the easiest way of doing that. It's not the best way. We should be using tools like HashiCorp Vault or AWS Secrets or Azure Key Vault. That's what we should be doing, but that takes work and doesn't always happen, which is why, as DevSecOps engineers, we need to find ways of searching for these when they happen, or putting in hooks to prevent this happening in the first place. So that's keys and secrets. So what I then did was to think about, well, how can we put this together in a bit more of a framework? And this is what I put together. So there's three elements in my opinion, and based on my experience, of an effective continuous cloud compliance framework. The first is prevention, and prevention can include policy as code. So this could be Terraform's Sentinel, it could be Azure policies, it could be service control policies in AWS through AWS organizations. That's one method of prevention, and that's the ideal method because it automatically applies to the whole AWS account or the whole subscription. But that won't cover all of the use cases. Integrating tests to the CI/CD pipeline is the next best thing, because then a DevOps engineer can't merge his branch or her branch to master unless it passes the tests. And if there's a test in there to enforce policies, that's great, because that's preventative. So prevention is always the best approach, but it's never going to necessarily be 100%. So detection is the next aspect. And that's also important for automated audit. This can include infrastructure scans as well as application scans, and should also include, or could include, a data discovery element like Amazon Macy to look for items in S3 buckets, or indeed, as I just showed you, keys and credentials in either public or private code repositories. And even prevention and detection isn't enough by itself. In my opinion, there has to be a remediation and enforcement aspect as well. Serverless functions are great for this. So in the case of AWS, that would be Lambda. With Azure, that might be Azure Functions or Logic Apps or PowerShell runbooks. So I think bringing those together, all those elements are really essential for a comprehensive continuous cloud compliance framework. I've shown you a whole lot of open source tools. There are, as well, many vendors who work in this space and who have cloud solutions that do some of this. And many of them are very good. However, I would just say that most of them will only really play in one or two of these areas effectively, not all of them. So a complete solution is likely to include several different technologies and approaches. So that's all I have to say on this. Anybody who wants to contact me, here are my details. I do a blog on cloud security and DevSecOps, which you can find on my website, www.celidor.co.uk, or also on LinkedIn. And I'm the only Paul Schwarzenberger who works in security at the moment, so you won't have any trouble finding me. Feel free to connect. So that's the end of my talk. We've got 4 minutes left for any questions, comments. So, yep, go ahead. Third row. Oh, and Francois running.
Thank you very much. In the example where with the security group enroll, have you considered also attaching or using CloudTrails to extract the user role or IAM user who actually created it, or a role if you are using assuming or something, to also post it in Slack to address that this was happened because of this person or something like that?
Yeah, so the question there was where we were trying to identify who actually created the security group or did that action. In the piece of work that I did, I didn't actually include that. However, generally speaking, we had a policy of including the environment name within the tags of the security group, and sometimes within the name of the security group. So that did help to identify, who actually did that. But effective tagging is also another method that can be done. I mean, it's definitely possible to do exactly what you said. Go back through CloudTrail and identify who actually did that action. It wouldn't be that hard. And it wouldn't be that hard to automate it. That wasn't a piece of work I actually did, but it's a good idea. It would be a good enhancement, definitely. Any other questions? OK, don't think so. So, yeah, we'll finish there. Thank you very much. OK.
Thank you very much.